Welcome back. In this video, we will learn about chi-square test. What is chi-square test? It is a tester of null hypothesis. That means whether you should reject the null hypothesis or you should not reject the null hypothesis. So that decision you can take by performing chi-square test, right? Now, in two cases, you can use a chi-square test. The first one is the association between categorical variables. Remember, categorical variables, not numeric variables, but categorical variables. And you want to find any dependency or any kind of association between those variables. So, for that, you can go for chi-square test. And the second one is that you can also find out the goodness of fit for the data pattern you have collected. Now, I will show one by one these two cases. Let's start with the chi-square test for determining association between two categorical variables. So, your chi-square test will determine whether there is a significant association between two categorical variables. Keep these three things in mind: significant association, two categorical variables, not three, not four, but two categorical variables. Now, these categorical variables are also known as qualitative variables, and the other type of variables are quantitative variables. Those are also numeric variables. But here in categorical variables, you will not find numbers, so these are non-numeric variables, right? So, for example, we take the movie. And in movie, there are so many features, and out of those, we have taken these two features. The first one is genre. In India, we call it genre. And the other one is ROI. ROI means return on investment. It is return on investment. That means simply straightforward, it is to say that it's a profit. That means you put some money into the production and you expect some profit from the movie, right? So that is ROI. So that is a return, right? Now, these two variables are categorical variables because you can see the data here is comedy. The movie may be comedy type, the movie may be romantic type, maybe thriller type, maybe sci-fi type, or like that. And on the other hand, in case of ROI, we have taken low ROI, high ROI, or medium ROI. So, both these variables, you can see that these are categorical variables, that means non-numeric variables. And you want to see whether there is a relation or some association existing between this genre and ROI. Whether genre is a deciding factor for the better ROI. That means based on the comedy or romantic or thriller or sci-fi, whether you will get a high ROI or medium ROI or low ROI. Clear? This is a formula for chi-square. Now, this Greek x is your chi-square value. It is x squared, is written like that. And it's a sum. It's simply a sum of some components. What are those components? See, this OI is the ith observation or observed frequency. And this EI is your expected frequency. Now, if you have n observations in your data set, then your I will run from 1 to n, and for each OI or the observed frequency, you have to go for an expected frequency which is not available in your collection. So, you have to calculate EI for each OI and simply plug the data inside and you will get the chi-square. It's so simple. Now, here we go with an example. We have the genre on this side, G-E-N-R-E, genre, and we have taken two genres, like, right? The sci-fi is the first one and we call it sample A, and the second one is comedy and we call it sample B. And on this side, we divided the ROI into three types or three groups. The first one is high ROI, the second one is medium ROI, and the third one is low ROI. So, we call it groups here on this side, and we have samples on this side. Now, these are the data we have got. We can see that 65 sci-fi movies gave you high ROI. 22 sci-fi movies gave you medium ROI and 17 sci-fi movies gave you low ROI. On the other side, regarding comedy movies, you have 55 comedy movies that gave you high ROI, 28 gave you medium, and 23 gave you low ROI. Now, seeing this figure, can a producer decide whether any dependency is there between this genre and the ROI? Now, seeing this figure, you can see one thing, that see 65, here the 65 is higher than 55. So, from here you can say that okay, sci-fi movies are much more profitable than the comedy ones. Now, go to the last row. Sci-fi movies low ROI is only 17, where the comedy movies low ROI is 23. So, in these two rows you can see that clearly that the sci-fi wins. And in the middle row you see that for the medium ROI, sci-fi goes for 22, whereas the comedy movies go for 28 with the medium ROI. So, we want to know whether the frequencies or the occurrences, these are the frequencies, the 65, 55, all these are called frequencies or the occurrences, is related to the genre of the film. That is, we want to know if sci-fi movies show a different pattern of ROIs than the comedy ones. Because if they have some kind of difference between them, we can say that the genre is affecting the ROI. But if we see that the sci-fi movies and the comedy movies are showing same pattern for ROIs, then it is needless to say that the genre has nothing to do with the ROI, right? So, here we go with the step 1. The step 1 is set up the null hypothesis first. What you want to know, that will be your statistical question, right? Next, you calculate the expected frequency for each observed data. I already mentioned that the observed data is already available here. You need to compute the expected frequency for each of those observed data, right? So, this is your step 2. Next, step 3. Calculate the chi-square score of the given data, because you are ready to go, because you need only two things, the observed data and the expected data or the expected frequency. That's all. And the next one is calculate the degrees of freedom, because here degrees of freedom matters. And for the step 5, you will have to go for consulting the chi-square table, which is available everywhere in books, on the internet and other places. And then you have to take the decision whether your null hypothesis will be rejected or not to be rejected, right? So, here we go with the formula here we have seen before. Now, this is our step 1. First, set up the null hypothesis. What is your null hypothesis? There is no significant association between genre and ROI. Null hypothesis always tries to remain in a neutral position. It says nothing has happened. Okay? So, there is no relation between the genre and the ROI. Genre goes in its own way, ROI goes in its own way. So, there is no relation between these two. So, that is the statement of null hypothesis. And the alternative hypothesis is there is a significant association between genre and ROI, right? So, this is the first thing you have to do. The question, the statistical question you have to mention first. Next, we go for the step 2. In the step 2, we are going to calculate the expected frequency for each observed data. See in the formula here, for each OI is already available from here. But in case of EI, you have to compute that. So, you have to compute the expected frequency for each observed data or observed frequency. The formula is like this. Its row total divided by grand total multiplied by its column total. Now, you have to calculate all the totals over here. I will show you after this. Now, the thing is that its row total means, if you talk about 65, the first data over here, 65, the 65 is standing at row 1. So, we are talking about the row 1's total. For example, if you talk about 28 here, here you go for 28, it is in the second row, then we are talking about the second row's total, right? So it's row total divided by grand total. Grand total means all the movies, whatever you have collected, the total number of movies you have taken as a sample, multiplied by its column total. Column total goes like this. That means how many sci-fi movies you have collected, or how many comedy movies you have collected. So these totals are column totals, right? Now the thing is that this row total on this side, that means how many high ROI movies are there, how many medium ROI movies are there, or how many low ROI movies are there. So if you go like this, that row total by grand total, that means you are talking about proportion. That means what is the proportion of high ROI movies out of all those movies. In case of the second row, what is the proportion of medium ROI movies out of all those movies. So that is a proportion actually you are talking about. So actually you are multiplying the proportion with its column total. So that is the case actually, right? So here we go with the column totals, row totals here, and this grand total. You can see that if you add this 65 with 55, then you will get 120 here. That means 120 movies are there in our sample which are showing you high ROI. Okay. So in this case, medium ROI, 22 plus 28 will give you 50. That means 50 movies are there in your data set or in your sample which are medium ROI. And in case of low ROI, you have 40 movies. So if you add these three, then you will get 210 here, right? Let me change the color of the pen. Okay. Next, let me clean it up. Okay. Now you go by the column 1. You have total 104 movies which are sci-fi and 106 movies which are comedy. And those also, if you add those two, then you will get 210. So if you add this side, come from this side or from this side, definitely you will get the figure 210, right? So this 210 is your grand total. Okay. So this is the total number of movies you have in your sample. Clear? Next, we calculate the proportion first, then we will multiply the column total to get the expected frequency, right? So let us go for the proportions. The first one, this P1 is 120 by 210. That means this 120 is here and this 120 out of 210. So this will give you the proportion of high ROI out of all those movies, right? So this one will be P1. So P1 goes with this cell, P1 goes with this cell also, right? So get it a suffix. This will be a suffix I have given in the explanation. There is suffix, right? And in case of P2, you have 50 out of 210. So you have 50 medium ROI movies and out of 210, so that will give you the proportion 2. So proportion 2 will go with this one, P2, here also P2, right? And in case of P3, it is 40 out of 210. So P3 goes here. Clear? So you have got all those proportions. Now you can go for the expected frequencies individually. So for E1, that means this first cell E1, you have P1 times 104, right? So P1 is multiplied with 104. So E1 is 59.43. So you can write like this in bracket, 59.43, right? So this is your expected frequency. So your observed frequency is 65 and your expected frequency is 59.43. Similarly, you go with the E2 and E2 is P1 times 106. So if you go for this 55 is having its total, column total as 106. So you multiply the P1 with 106 now and you will get 60 2.57. So write it in bracket. So here you go with the E2. Similarly, you can go with the E3 and E4. So E3 will be, now E3 means this cell, this 22. Okay. So this 22 will be, this P2 will be multiplied with 104 because 22 is standing on the row 2 and the row 2 is dealing with P2. So P2 times 104, this one will give you 24.76. 24.76. And on this side, and in this case, this 28, it is also dealing with P2, but it should be multiplied with 106, right? So if you multiply that, then you will get 25.24. Similarly, for E5, E5 is dealing with 17. 17 is in row 3. So you multiply this P3 with 104 and you will get 19.81. And in case of 23, it is 20.19. So you have got all the expected frequencies for each observed data. So this is our step 3. Calculate the chi-square score of the given data. So since there are 6 data points or the 6 scores, so our n will be 6. So our n here is 6 now. So your summation will run from 1 to 6. Okay. So you expand this. So the first term will be O1 minus E1 squared by E1. This is the first term. This is the second term. This is O2 minus E2 squared by E2. So in this way, you get the third term, you get the fourth term, this is the fifth term, and this one is your sixth term, right? Now plug in the values. I will explain you the first term only. The O1 is having 65. You see, here is 65. O1. So observed data 1 is 65 minus the corresponding expected frequency for 65 is 59.43. This one, 59.43. So 59.43 is here, and you square it, and then you divide it by E1, that is 59.43. So similarly, you go for the other terms here, other 5 terms, and you will get the value. If you go for the computation, and you will get the value as 2.61. So this is your chi-square score. Next, we go for step 4, and in step 4, we go for calculating the degrees of freedom. Now, here we have degrees of freedom as row count minus 1 times column count minus 1. Now, row count is actually 3 because this is the first row, second row, and third row. Do not include this fourth row because fourth row is we have done for summing up those data. And also on this side, do not include this fourth column because the fourth column is also for summing up the data. So you have only 2 columns here, this one and this one. So we have 3 rows minus 1, 2 columns minus 1, and you get 2 here, right? So degrees of freedom is 2. Now we choose significance level as 0.05, that is 5%. You can choose other values also, 0.01, that is 1%. Now regarding this significance level, it is a threshold for rejecting the null hypothesis. That means if your score is below significance level, then your null hypothesis stays. And if your score goes beyond the significance level, then you reject the null hypothesis, right? Because the significance level is actually 0.05 means there's a 5% chance of making a type 1 error, right? The type 1 error is actually you are falsely rejecting the null hypothesis. That means the null hypothesis is true, but by mistake, you are rejecting that null hypothesis, right? So that is the meaning of this significance level, right? So we consult the table here. Well, let me clean this up. Okay. So you have this table and we are dealing with significance level 0.05. So we will deal with this column. Here you go with 0.05, and we have a degree of freedom as 2 here. So we will deal with this row, and we have got the value of 2.61. But here you have this 0.05 on this column, and this row is giving you 5.991. So this is your value, or this is the critical value. This is the critical value, right? So you have the critical value at 5% significance level with DOF equal to 2 is 5.99. But our obtained value is 2.61. So 2.61 is less than 5.99. That means you are within the range, or you are within the threshold. So since you are within the threshold, we failed to reject the null hypothesis. That means your null hypothesis stays. The meaning is that there is no relation or no association between this genre and ROI. So this is your null hypothesis. This is true and this stays, right? So in this way, you can go for finding any kind of association present between two categorical variables using chi-square test, right? Now you go for the second case, that is chi-square for goodness of fit. Suppose we have a data like this. So this is not a tabular data or a 2D matrix. It is a simple, straightforward 1D data we have. And we consider the high ROI only. So in case of high ROI, the sci-fi sample A is giving you 35 pieces of movies. Comedy is giving you a sample B of 20 movies. Thriller sample C, 28 movies. Romantic sample D, 34 movies. And the total count is 100. That means you have collected 100 movies. So you have taken a sample of 100 movies, and out of those 100 movies, you have got these numbers. Okay. Now, the same thing goes. First, you set up the null hypothesis. You say that the null hypothesis is there is no significant association between the genre and the high ROI, right? So there is no relation between the high ROI and the genre. And the alternative hypothesis is there is a significant association between these two, right? So for step 2, you calculate the expected frequency for each observed data. So you have 4 observed data here. So you will have 4 expected frequencies, and the formula will be like this. It's row total divided by column total. Now here is only one row, so always the row total will be 100 for each of these 4 cases, and the column count is 4. So it is simply E1 is 100 by 4, that is 25. E2 is 100 by 4, that is 25, like this. So all E1, E2, E3 and E4 have got 25, because in each case there is only one row and the column count is static, that is 4. It is fixed. So 100 by 4, 100 by 4, 100 by 4 and 100 by 4 for all these expected frequencies. So you get 25 in all the cases. So here you go. Expected frequency is 25 in all the cases, and if you add these 25s, then you will get 100. Next, you go for step 3. So you have got these OIs and you have got all the EIs. So this is the time for getting the chi-square score. So here you have 4 observations. So here n is 4 now. So I runs from 1 to 4. So OI minus EI squared by EI, the same formula. So this is the first term, this is the second term, this is the third term, and this is the fourth term as before. So plug the values in and you will get 8.6. So this is your chi-square score for this situation, right? Now we go for step 4, and here we calculate the degrees of freedom. So this is a 1D data. So the DF will be column count minus 1 only, because there is no row. So 4 minus 1 will give you 3, right? So we have degree of freedom as 3. So here we also take the significance level as 5%. So you can take any other significance level also. Now we consult the table, and for this significance level 5, so this is our required column, and in this case we have degree of freedom as 3. So here we go with the this one, this degree of freedom is 3 here, and along with that we have got this value, this 7.815. So this one will be our required critical value, right? So the critical value for 5% significance level with DOF equal to 3 is 7.82. Okay, so I have rounded it up for 2 decimal places. So 7.815. So it is 7.82. Sorry. Now you see that we have got 8.6. And your table shows a critical value of 7.82. So our 8.6 is greater than 7.82. So in this case, our score is beyond the critical value of 7.82. So we reject the null hypothesis. That means the alternative hypothesis is true. And what the alternative hypothesis says? There is a significant association between genre and high ROI. So this is the case. So that is all with chi-square test. So there are some limitations. So the first limitation is these are categorical variables. Number 2 is sample size must be large. Sample size must be large. And third point is that chi-square assumes that there are independency between the variables. And the fourth one is that chi-square does not show the direction of association. Because in this example you see that the chi-square says that there is a significant association between genre and high ROI. That is true. But the thing is that it is not showing whether genre is a deciding factor of high ROI or the high ROI is a deciding factor of genre. So that kind of direction is not displayed by the chi-square, right? So these are the 4 major limitations you have in chi-square test. So in the next video, we will go for Yates correction. So this is used for, this is a kind of adjustment in chi-square test whenever your expected frequencies are very close to 0. In that case, the chi-square test may give you some erroneous result. And the second thing is that if you have a small sample size, then also you will be in trouble. So in these cases, Yates correction will help you to find out a better chi-square score so that you can take a decision. That's all in this video.